Hey, geometry friends, here we go. The last assignment for chapter 1, and that is a review. So another chance to practice some of the same skills we've been working on the last several weeks before we celebrate on Friday. And this is page 61 through 39 odd. And again, um, some of these answers should be, I think, in the back of your book, but I am going to post solutions with the assignment just in case they're not all there. Okay, so I've selected a couple problems. We're going to do 9, 23, 27, 31, 33, and 37. Um, and number 9 is a drawing, an example of having to draw what is being described. And so number 9 says draw and label each of the following. Number 9 says line CD intersecting plane P at point B. Okay, so we need a plane or a line going through a plane, not along a plane, but through a plane at point B. So I'm going to go ahead and start with the plane, which again I usually kind of draw as a piece of paper or like a parallelogram. So there's our plane, and that's supposed to be plane P. So I'm going to label that plane P. And now we have a line going through it. And so the way you can kind of draw that, which can be tricky, is if you just draw it like this, and then as if it were going through this point right here, I would draw the rest of it as like a dash. Whoops, that doesn't look very good. A dashed line coming out the bottom. So as though that, like a pencil going through a piece of paper. And so that line is line CD, and I can make it that by putting those 2 points on that line. And then the point at which it's passing through the plane P is point B. So that's what's being described there. A line CD going down through plane P at point B. Just wanted to review that because it's kind of convoluted, but also, I mean, obviously you're not going to be drawing on the test, so probably don't need to worry too much about that one. Okay, number 23. 23 is one of those potentially tricky expression ones using supplementary and complementary angles. 23 says, find the measure of the complement and supplement of each angle. And again, I think it's kind of tricky because when it says find the complement and supplement, you kind of hope you're going to find a number answer. Whereas because they're giving you this just as an expression, your answer is also going to be an expression. Let me show you what you mean. If this angle is complementary, that means it's part of a 90-degree angle. So we could picture it looking something like this. Here's a 90-degree angle, and then this angle would be inside of that at 2x minus 4. And if you remember, so how would I express the complement of that, which is right here? Well, it would be the total angle, because I do know the total. So the total angle minus the angle I know equals my unknown angle. So my total here is in fact 90 degrees, so 90 minus the 2x minus 4. That would be equal to whatever the other angle is. And again, it's kind of frustrating because you can't know what that number actually is, but we can express it in terms of x. And then, so just a reminder, I put that expression, notice in parentheses, so I want to distribute my negative. So this is the same as 90 minus 2x plus 4, which then if I simplify is negative 2x plus 94. Okay? So that would be this question marked angle up here, and that would be the complement of the angle. Alrighty. Now, what if it was the supplement? Let's look at that. No, we'll draw it in black. All right. So now imagine supplement means they add up to 180. So now imagine this angle was simply here, and here's my 2x minus 4. You don't have to draw these. I'm just trying to demonstrate it. And it's now part of a larger 180-degree angle. Well, it's the exact same process, except now we know 180. So it'd be 180, which would be this unknown angle right here, minus, or 180 the total, minus the 2x minus 4 would then be equal to this unknown angle here. So now let's go ahead and distribute the negative. Okay, easy way to get the slightly wrong answer, so be careful and be sure to always do that. So we have 180 minus 2x plus 4 again, and so that's just going to be 184 minus 2x, which is a perfectly acceptable answer, or you could go ahead and do the negative 2x plus 184. Whoops, I said 184, but I didn't write it. That should be 184. So I think I did. All right, so negative 2x plus 184. Sorry, that 184 looks kind of bad. So again, when they ask you just to express a complement or a supplement, take the total, either 90 for complement, 180 for supplement, and then subtract the given expression. Make sure you put the expression in parentheses, distribute that negative, and you'll have another expression representing that missing angle. Okay, 27 is an area perimeter problem with a triangle. Again, but kind of like the previous problem, one of the sides is expressed as an expression with x, a variable. So our final answer is not going to be just a number, it's going to be an expression. But let's go ahead and work through both. So we have the perimeter, distance around, simply add up all the sides in this case. So 8 plus 12 plus x minus 5. Okay, because those are the three sides. I got my like terms here. I have 8, 12, and negative 5. So that's going to give me 20 and then 25. And so we get, let's see, where are we? 27. 8 plus 12. Oh, I'm sorry. 8 plus 12 minus 5. There we go. Saw something going wrong there. Help me out. Speak up. Talk louder when I make a mistake. 8 plus 12 is 20. 20 minus 5 is 15. So 15 plus x is equal to my perimeter. Just checking my answer. That is correct. So notice the x is still part of my answer. And again, you're just adding up the sides, in this case, to find perimeter. Area is, if you remember, area of a triangle would be 1/2 base times height. Alrighty, so what's my base? My base is, so I've got 1/2. My base is x minus 5. And my height is 8. So we got to go ahead and simplify this. Now again, I would not distribute that 1/2 fraction into the x minus 5. I would always, always, always apply that 1/2 to anything I can evenly cut in half. So in other words, I want to cut that 8 in half before I have to do anything else. Because the order that I multiply those three things, the half, the x minus 5, and the 8, doesn't matter. So first I'm going to do 1/2 times 8. Because then that nicely simplifies this simply to x minus 5 times 4. Okay, which is half of 8. Now I can more easily just distribute this 4 into my parentheses, which will be 4x minus 16. Oh, I'm sorry. Oh, it's a 5. Let's fix that. And then so you can see why showing your work is so important. 4 times 5, so 4x minus 20 is actually what I would get for my area, equals area. So notice both answers still have the x as part of it because we don't know what x is. If we did, we could immediately plug it in and solve. But starting from the formula, again, multiplying that 1/2 times something that easily cuts in half, to me, that's a really easy tip. And there we go. Perimeter, all the distance around. Area, the distance covered. Perimeter, a lot of times you can just add them up. Area, we're using our formulas. Okay, 31, another area problem. But again, wanted to work with you through it because it's one where they've given us the answer and we have to go back and find one of the dimensions. Because here we have a triangle and it's described. So again, I highly recommend it until you're just absolutely acing everything to go ahead and draw these out. It describes a triangle where that has a base of 17 meters and an area of 102 meters. So we don't know the height. It wants you to find the height. Well, just write out your formula and we will plug things in. So area is 1/2 base times height. Only now I know my area, which is 102. 1/2 times my base, that's 17, times my height. Okay, so in this case, a couple of different ways you could solve it. The opposite of, well, I could multiply 1/2 times 17. That's one way to do it. Let me just make sure I have my dimensions right. Yeah, I could but then it is going to be a fraction, so that's up to you if you want to do that first. The other thing you could do is the way of undoing multiplying by a half is multiplying both sides by 2. So let's try it. Let's just try it that way. So because 2 times 1/2 is equal to 1, so that's like it cancels out to a 1. And then that leaves me with a 204 over here. 2 times 102 is 204 equals 17h. And so now how do I solve for h? I simply divide by 17. And this, I have no problem with you pulling out a calculator. Again, I could do the long division, but that's not what I really want you worrying about using your brain power on. You're welcome to if you want to. 204 divided by 17, that is 12. So that cancels out, and we are left with h is equal to 12. Alrighty, and units are meters, so don't leave naked numbers, 12 meters. And if you want to know if that's right, it's simply just plug it in. 12 times 17 divided by 2 will give you 102. Alrighty, so working backwards. Make sure, just like the midpoint, where they give you the midpoint and an endpoint, in this case, they're giving you the area, the answer. You got to go back and find the missing dimension. Now you could just simply work through it backwards using your algebra skills. Okay, 2 more problems, 33 and then 37. 33, I just described it. It's a midpoint problem. And they've given you not the 2 endpoints, but they've given you the midpoint and one of the endpoints. The one endpoint is here at A, and it is 5, 0 over 5 up 0. And then they've given us Y as the midpoint, which is -2, 3. So we need to then find the unknown, let's go up a little bit, the unknown endpoint B, which would be somewhere up here. And again, it's good to draw it because when I get an answer, I'll be able to look and see, is this actually accurate? Lots of ways to do this. I recommend, as I continue, just to count out the vertical change with the horizontal change, because that will be mirrored in how we then find point B. So let's do that right now. So to get from A to Y, I have to go up 1, 2, I have to go up 3. So from Y, if I go 1, 2, 3, I know that that's going to be the height of point B. And then I can see the horizontal change is 1, 2, 3, 4, 5, 6, 7. Alrighty, so that means this point is going to be a change of 7. 1, 2, 3, 4, 5, 6, 7. And that means point B must be right here. So we can kind of eyeball it and see, yeah, that looks like the midpoint. Y now looks like the midpoint. And so I just need to know, where is that point? It's at 1, 2, 3, 4, 5, 6, 7, 8, 9. It's at -9. 1, 2, 3, 4, 5, 6. -9 up 6. So there is my new endpoint. Check that in the book. Yes, that is correct. Again, graphing it makes it shows you that it works. You could do that mentally. You can see the difference between 0 and 3 is just 3. So if you add 3 to 3, you get 6. You can see the difference between 5 and -2. If you subtract them, is 7. So if I subtract 7 more from -2, that gives me the -9. So to me, that's the easiest way. And again, the number one thing is just make sure when you have a midpoint problem, did they give you the 2 endpoints and you're finding the midpoint? Or did they give you an endpoint and a midpoint, and then you need to figure out where that other endpoint is? All right, last one, 37. 37 is just the good old length of the segment problem. Use our distance formula or the Pythagorean theorem. And so the key here, again, is we say the Pythagorean theorem because if we know the legs of a triangle, we know that of a right triangle, we know that a squared plus b squared is equal to c squared. So take your segment and turn it into a right triangle by finding the vertical and the horizontal. There it is. And then you can just count out the legs. Notice they didn't graph this. I graphed it because, again, to me, it's easy to work visually. If you get good at it, you don't have to. But the vertical change is 1, 2, 3, 4. The horizontal change is 1, 2, 3, 4, 5, 6, 7. Okay, and again, even if you didn't graph it, you can just look at the numbers, and I can say, well, what's the difference between -4 and 3? Well, if I subtract those, because that's how you find the distance, Negative 4 minus 3 is 7. So that's where I got the 7 from. What's the difference between the 2 and the negative 2? Well, I can subtract those. I can see the difference is 4. So whether you do it just with the arithmetic or whether you graph it and do it like I did, counting out the spots, you should be able to find your A and your B. Okay, then just apply the formula. 4 squared plus 7 squared is equal to C squared. So that's 16 plus 49 is equal to C squared. That's going to add up to 65, I think, equals C squared. And then we solve the opposite of squaring is square rooting. So that'll take our C back to C squared to C. Oops, it doesn't look good. C equals the square root of 65. They asked us to round to the nearest tenth, so that means they want us to crunch the number. So pull out your calculator, and the square root of 65, which if you run through your squares, 8 times 8 is 64. So this has got to be something really close to 8. And in fact, it is. It's 8.1. Since 8 times 8 would be 64, 65 would just be something a slightly bit bigger. And so it is approximately 8. Rounded to the nearest tenth, that's 1 decimal place. 8.1. There she is. All right, distance formula. Again, just find your a squared plus b squared is the distance, c squared. It's the hypotenuse of that triangle. So find your vertical change and your horizontal change, either visually or just subtraction, and then you'll know what your a and your b are, so you can plug them in. Alrighty, so that's the chapter review. Hopefully a lot of this is easy. You want to pinpoint the types of problems that are difficult for you and do extras of those, or reach out to me so I can give you some extra practice. The key is your own motivation. If you want the help, I'm here to do it. If you feel like you're completely lost, don't try to fix everything at once. Just work on one type of problem at a time. And once you feel confident on that, then go ahead and move on to the next. Okay, so please reach out if you need help. And Friday, we will be celebrating all that we've learned.